Hi, I'm Karthik and Ranjan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the technical director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CAS. I learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSI and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he's doing how real digital marketing works. and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exam to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XL for teaching us.
Good morning, everyone. Hope you are doing good today. Is my audio and video clear to you all? Can you confirm me through chat box? Yeah, good morning. Is my audio and video clear? I didn't see any responses. Okay, great. Thanks for responding. Respond and let me know if you have any doubts through chat box, and make it as a interactive session. So in SD session we discussed about a few programs that to using strings in Java, right? Do you have any questions or doubts in previous sessions, or can we proceed today's session? Any doubts, or can we proceed? Please respond, guys, so that I could understand your concerns. No doubts? Yeah, great response. Thank you. So let's start today's session. Let me share my screen. Hope my screen is visible to you all. Okay, great. So in today's session, we are gonna discuss about data structures, why data structures are needed, and we'll see basic searching and sorting techniques. I'm not sure how many programs we can complete, like how many sorting techniques we can complete, but we'll try as much as possible today. If anything is pending in today's session, we'll move it forward to next week's session. We'll discuss that. So, have you heard about data structures and algorithms? Do you have any prior knowledge on it? Yeah, if it is yes, why we need data structures? Yeah, to organize the data. Great. So, data structure is nothing but it is used to store the data in such a way that it will organize the data, so that it is easy to process and it is easy to perform operations on the data. Let's take quick example. So if I gave you this room, I mean this room consists of many books, and those are not organized actually. So if I ask you and if I ask you to find particular book, maybe or social studies, eighth class social studies book. So will it, how you will search it in this room? You have, how you will search for that particular book. So you have to enter into that room and you have to check one by one, right? Whether that book is social studies eighth class book or not. So once you found it, you can come and hand over that book to me. So this is how you can search in this room, right? So what if my room is like this. My room consists of books, but those are in very organized manner. Like in each chamber, I'll maintain it as this is for social studies books, and these are physics books, these are chemistry books, these are motivational books, these are love story books. If I organize it in such a way, and if I ask you to find particular book, that to social studies, eighth class book, will it take time? How you will do? You will come to this room and you will search for that particular chamber, like particular stream or domain, social studies domain, and based on that you will search from first class, second class, third class, and all those classes books, and you will find out the sixth standard social study book, and you can take that and you can hand over to me, right? So uh, if you, I mean, which one will take extra time, extra effort? If I ask you and if I give this same task to you to find the social study eighth class book, will you easily find it in messy room or in organized room? Which one is better? Which one is better? The messy room or organized room? I need more responses. Only Pranjali is responding. What about others? Are you all there in the class? Okay, okay. Great. So, similar to this real world example, if you have some data and you need to do some project or you need to implement something, better to organize the data. So, if you are organizing the data, it is very easy to perform operations and to perform tasks on it, right? So that's the reason we are having data structures. The name itself it is saying it will structureize the data, it will organize the data. So once your data is organized, it is easy to perform all the operations, right? So that's why data structures came into picture and it is very, very important. It's not like program specific. It is we have data structures and algorithms in like all the languages. Give me a minute. Sorry. It is these are like techniques and these are like how to structureize the data in better way, in efficient way. So it is like a technique, right? So you once you learn the logic or technique or how to structureize the data, you can perform it in any programming language. It's not syntax centric. Okay. So let's focus in today's session. Let's discuss about searching first, searching techniques first, and then we'll go for sorting. So the first thing is, in the same example, in the messy room, as the books are not in organized way, you will enter into the room and if you have to search one after other, right? I mean, one by one, you have to search whether this book is social study book or not. If it is not, you have to keep away. So, and you have to repeat this searching until you find that book, right? So that is nothing but linear search. What is search actually? What is search? You will be having some data and you'll be having a target element, and you have to find whether the target element is exist in the data or not. This is searching, right? So searching is divided into two types. One is linear search and another one is binary search. Linear search is nothing but searching one after other. searching one by one element and then one other element and then other element until we found the element or until all the elements are completed. Okay. So I have a array 8, 5, 5, 2, 4, 3 maybe. And I gave you the target element as 4. Is 4 exist in given array? Yes, it is existed, right? So you need to, if it is existed, you have to provide it is found. If it is, for example, if I give you the target 6, if I give you the target 6, is 6 present in given array? No, it is not present. So you have to print not found or else element doesn't exist in given input. Okay. So how can you do this? Can you tell me how can you usually do this? Yes, using loop, and we have to iterate over entire array, and when on each iteration we have to check whether this element is target element or not, right? So let's quickly do that. So it's nothing but for int I equal to, we need to start from first element like 0th element till n minus 1. N is nothing but I'm assuming array length. Okay. And each time I should be incremented, right? So here I have to check, I have all the elements. So for each iteration, I have to check whether that array element is equal to my target element or not. If it is a target element, I'll print target element found or target element exists. Okay. And then I'll return it. I mean, return is nothing but I won't return anything, but I don't want to do the search for other iterations. For example, if my element is found at this position, I just give like I can print like found, like the element is exist. That's it. I don't want to repeat the iterations, right? So that's the reason I'm not returning anything. Like return and then semicolon. It means we are not returning anything. Okay. So once you are I mean mention this statement, it won't return anything, but it will stop executing further iterations. Okay. So once this is done, I mean once for example here, let's do the dry run for this elements itself. So on first iteration, what will be my I value? I will be 0, right? I will be 0. Minimize this. Yeah. On first iteration, what will be my I value? I will be 0. And is 0 less than or equal to what is the n value? N is nothing but size of the array. 1, 2, 3, 4, 5, 6. There are 6 elements exist. So 6 minus 1, 5. Is 0 less than or equal to 5? Yes, it is less than or equal. It is less than 5. So it will enter into the for loop. So in the for loop, what we are checking? We are checking whether our element a of 0 is equal to 4. What is target element? 4. What is a of 0? The index is 0, 1, 2, 3, 4, 5. Okay. So is 0 equal to 4? No, it is not equal. So it won't go inside the if condition. So after second iteration, I will be 1. My I will be 1. Is 1 less than or equal to 5? Yes, it is less than. So I'll check a of 1 is equal to 4. Is my a of 1? What is a of 1? 5. Is 5 equal to 4? No, it is not equal. So it won't go inside if condition. So then I will be incremented on the third iteration. I will be 2 and 2 less than or equal to 5. It is true. 2 is less than 5. So I'll check whether a of 2 is equal to 4. What is a of 2? What is our a of 2? It's 1. Right? Is 1 equal to 4? No, it is not equal. So it won't go inside the if condition, and it will increment the I value. On the fourth iteration, I will be 3. Is 3 less than or equal to 5? Yes, it is less than. So I'll check A of 3 is equal to 4. What is A of 3? A of 3 is nothing but 2. Is my 2 equal to 4? No, it is not equal. So it won't go inside if condition. So on the fifth iteration, what will be my I value? My I will be 4. Is 4 less than or equal to 5? Yes, it is less than 5. It is true. So I'll check whether my A of 4 is equal to 4. What is A of 4 here? What is the element at fourth index? It is 4, right? So 4 equal to 4. Yes, it is equal to 4. So as it is equal, as the condition is true, it will go inside if condition. In if condition, what we wrote? We just printing that target element has existed. So it will print target element exists. And after that line, we have written and we are not returning anything. So it will just stop. It won't return anything, but it will just stop and it won't execute further iterations. Okay. So did you understand? Yes, if you return it, it won't do anything. Like it will stop the iteration. I won't be incremented, Satvika. Okay, is it clear? So, for example, once repeat which one? After fifth iteration. Yes, after fifth iteration, I will be 4. Is 4 less than or equal to 5? Yes, it is less than 5, right? So, it will go inside if loop. It will check K of 4 is equal to 4. My A of 4, like array of fourth index contains 4 value. So, is 4 equal to 4? Yes, it is equal. So, as the condition is true, it will come inside if loop. So, in the if loop, what will happen? Here we are printing the output, right? So target element exists. It will print in the console. After that, here we have return statement. Once you have written statement, it will return. That's it. Whatever the value you have provided, it will return and it will go. It won't go to the next iteration. It won't go to the for loop and it won't increment I value. Okay. No, yes, after fifth iteration itself, it will true. So, in the fifth iteration, we have return statement. We are not returning anything. It's like nothing only, but we have wrote return and without anything. For example, normally if you return 1, it means we are returning one value, right? If you don't mention this, it is nothing, but we are not returning anything. It's like void only. But once you wrote this written statement, it will stop here itself. It it will break the for loop, you can say. It will come out of the for loop. Come out of the loop. Is it clear? So after return, as you wrote return, it will come out of the loop. So I won't be incremented. Is it clear, Satvika? Okay, great. So after this, for example, this can be of like I gave 4, right? What if I have 6? I didn't have 6, right? Let's assume like I have 6 here. I'm just giving target as 6. So is my 4 equal to 6? No, it is not equal. So it won't execute. Excuse me. So after that, I will be incremented, right? Iteration 6. I will be incremented. What will be my I value? I will be 5. Is 5 less than or equal to 5? 5 is not less than, but it is equal to 5. So the condition is true. So I'll check whether A of 5 is equal to 6. What is my A of 5 here? Here it is 3. So is 3 equal to 6? No, it is not equal. So it won't go inside if condition. So after that iteration 7 will happen. I will be 6. Is 6 less than or equal to 5? 6 is not less than 5 and 6 is not equal to 5. So the condition itself fail. So it will come out of for loop. Okay, it won't go inside for loop. But we didn't find that element. The target element is not there in the given input. So for that case, we need to say to the user, hey, the target element doesn't exist in given input. So that's the reason here after for loop, I'll write one more sys out and I'll say target doesn't exist or target element doesn't exist. Is it clear everyone or any doubts? Clear? Okay. So I'll tell you, yes, Nikita, I'm coming to that point. So mostly data structures is nothing but structurizing the data, right? In order to improve our program's efficiency and we are optimizing our program. So it will be treated in terminologies of time and space. Time complexity and space complexity. So time is nothing but, for example, it doesn't mean that how much time the computer is taking to execute that program. For example, I have a MacBook and you have some old configuration of Windows, like which contains very slow RAM and very low RAM, actually very low RAM, storage. So my definitely Mac having high storage and high performance. So if I run one program, it is taking just 4 seconds to execute. But in Windows system, as the storage and the efficiency is little bit slower, it is taking 8 seconds. The same program. So you can't say like Mac, I mean, my program is best. I mean, it is taking 4 seconds, it is taking 8 seconds, its complexity is 4 seconds in Mac, 8 seconds in Windows. This is not the case. Time complexity means number of steps that program or the computer taking to execute it. It's like number of steps the program is taking to execute the program or project. For example, I'll give you small examples. Um, I have int I equal to 1, I is less than or equal to 2, I plus plus, and inside it I have some sysout statement. So how many times this loop will run? How many steps it will take? The iteration will be 1 and 1 less than or equal to 2. True, right? After that, 2, I will be 2. 2 less than or equal to 2. It's also true, right? So after that, I will be 3. 3 is not less than or equal to 2. It won't go here. So can I say it is taking 2 steps? It is taking 2 steps. It is not 3 times because it is failing a third time, right? It is not going inside for loop. The for loop is taking 2 steps only, the entire for loop. Yes, it is 2 steps. So it is taking 2 steps to execute this for code snippet. For example, I have 3 here. When increment, it's not like that. Like you have I'm saying the number of steps the entire this code snippet is taking, not just this single statement. This entire code snippet. Okay. So for example, if I have, is it clear, Satvika and Likita? The entire for loop. How many times this for loop is executing? How many steps it is taking to execute? 2 times, yes. So what if I have 3 here? How many steps it will take? 3 steps, great. What if there are 6 here? How many steps? 6 steps, great. What if here we have n? How many steps it will take? N steps, exactly. So it will take n steps to execute this code snippet. That is nothing but time complexity, the number of steps that code is taking or the program is taking to execute. So always the time and space will be mentioned in big O notation only. There are omega notations as well, but mostly we'll use big O notation only to represent it. Okay. So this code snippet will take order of n times. Okay, is it clear? This is for time complexity. So, and this time complexity, we always assume and say for the worst case scenarios only. What is worst case means? For example, this linear search, the worst case scenario is maybe the target element is found at last position, right? We have to iterate entire array, and at last it is the target is existed. So definitely it will go till all the elements, right? And other edge case, other worst cases, if the element is not found. If the element is not found, anyway we have to iterate the entire array and we have to check, right? So these are nothing but worst case scenarios. Okay, is it clear? If the element is found at first zeroth position itself, it's a best case. But if the element present, or if it is not found, or if it is present at last index, it's like a worst case only, right? We need to search for each and every element. We need to compare whether it is equal to our target or not. Can you agree with that? Those are our worst case scenarios. Yes. So we have to assume, always we have to say it in worst case scenarios only. So for example, if I have two loops, maybe here, or else I'll start with one. I don't want to make it messy. So how many times this loop will execute? This both the loops actually. 4 times, right? Exactly 4 times. Do you want me to show you how many times it is repeating? Is it clear? It will take 4 steps. Is it clear, everyone? Or do you want me to do the dry run? Okay, clear, great. So what if we have 3 here? How many times it will run? Yes, Haripriya, you're correct. What about others? How many times it will execute? Okay, I'll write it here. 1, 2, 3, it will run. So for each iteration, 1, 2, 3. On the second iteration, 1, 2, 3. On third iteration, 1, 2, 3. So how many times it is going inside? 9 times, right? Yes, exactly. So what if it is 4 and 4? How many times it will run? Yes, 16. So if you observe the pattern, if we have 2 and 2, it is nothing but 2 into 2, it is running 4 times. If we have 3, 3 into 3, 9 times. If it is 4, 4 into 4, 16, right? So what if it is n and n here? N and n? Yes, definitely n into n, which is nothing but n square. So if this code snippet will take order of n square times. It will take order of n square time complexity. Is it clear, everyone? How to calculate the time complexity? It is nothing but number of steps it is taking. Okay, great. The space is nothing but coming to space complexity. And here itself, if we have m and n, how many times it will take? M and n. Yes, great. Order of n log n, I know where I said n log n. till now? We'll go one after other, Likita. It will be all. It will also. I'll explain that one as well. So far, I just discussed about order of n and order of n square only. So if it is m and n, so definitely m into n. Okay, the order of time complexity. So the space complexity is nothing but the extra space you are taking, the extra space that you are taking to execute the program. Okay, to implement the program. For example, I think in matrix we did transpose, right? I'll give you two arrays. These are inputs. Array 1 and array 2 will be inputs. I think you maybe you can add the elements. For example, 1 0 2 0 or else here and another is 2 1 3 2. So the sum will be 1 plus 2 3 0 plus 1 1 2 plus 3 5 1 plus 2 3. So for this, what we did, we took extra array, right? Extra matrix A3, and we did the iterations, and based on that we did sum and we added, right? Did you remember? I think we have that program. Arrays. Yeah, addition of two different. Yeah, see here we have both these arrays are inputs, but we are taking extra array 3 to get or to store the result, right? So this is extra space. So apart from inputs, if you are taking extra space, that will comes under space complexity. Okay. For example, if my array contains 1, 2, 3, 4, and array and I ask you to reverse it. So instead of reversing in this array, I'm taking extra array and I'm reversing it. So we are taking extra space, right? How much the size? How we declare this array size? How to declare this array, new array? So this is how we declare, right? A dot length only. Do you agree this? Which is nothing but if let's assume A dot length equal to n. Okay, so that means the space complexity is order of n, right? Did you understand what space complexity is? Apart from inputs, if you are taking any extra space, that will comes under space complexity. Okay, is it clear? Is it clear, everyone? Okay, but for example, yeah, sure. I'll repeat it. So apart from inputs, for example, I'm giving two arrays. Arrays one array. This is the input that user is giving, or in the program itself, it will we can the user can give. So apart from this, if you are taking any extra space, that comes under space complexity. Okay, here I gave one input array. This is the input, and you have to print output. So the output should be reverse of the input only. So 1, 2, 3, 4. So you have to reverse 4. You have to reverse it 4, 3, 2, 1, and you have to print it. For this program, definitely you need if you take extra array to store these elements, definitely it means you are taking extra array, right? Extra space to store the elements. So how many elements it will store? Definitely, if it is contains n elements, as it is the reverse of that array, definitely it will also contain n elements. So the space complexity will be order of n. Is it clear, Nancy? Okay, but in small programs, for example, if A and B is given and you have to provide A plus B output. For this case, these are inputs, so these are not extra spaces. This is given in the program itself, but you are taking extra space C to add these elements, right? which is nothing but 30. But this won't comes under space complexity. If there is single element like int, I mean in all in like trying to check the number of steps or extra space, we all in data structures and algorithms, we always ignore constants. Always ignores constants. For example, here I gave you one input and you have to return two outputs. One is reverse of it. One is reverse of it. Okay. And another one is maybe sorted array. Let's assume it is not sorted. So you have to provide sorted array. Here for these two cases, you are taking two extra spaces, right? Definitely this will, how many elements this array will contain? If this element contains n elements, definitely this element also contain n elements, right? And definitely this element also contain n elements, right? Did you agree that? Yes. So which is nothing but here we took extra n array, here also we took extra n array in the same program itself. So order of n plus order of n, usually order of 2n, right? But you have to ignore the constants. Why we are ignoring constants means, for example, if there are 10 power 9 elements, 10 power 9 elements. So multiplying 2 into 10 power 9 will make any difference? It won't, right? It's very, very less. For example, if you have 1 crore rupees and you are adding 1 rupee to it, will you say I have 1 crore 1 rupee, or will you say 1 crore only? Mostly we'll say 1 crore only, right? So we are ignoring the constant. Like adding small to big is ignorable. Here you have big element, I mean big value, and you are adding very, very, very small value. So it can be ignorable. So the constants are always ignored in while calculating the time complexity and space complexity. So even though it is imprecise, if you say imprecise, it is taking order of 2n only. But as we ignore the statement, sorry, constants, we'll say order of n only. Did you understand? Or any doubts? Okay, so this is how we'll calculate time complexity and space complexity. Okay. Um, so coming to our program, the linear search. So we have for loop, which is starting from 0 to n minus 1. And each time we are checking whether that element is equal to our target or not. If it is yes, we are just printing that and returning it. So in worst case scenario, for example, if our target is 6, how many times it will run? What will be the time complexity here? What will be my time complexity? Yes. I need more responses. Only Haripriya is responding. We already discussed order of n actually. No, it is starting from 0 to n minus 1, right? Nancy, 0 to n minus 1. So definitely n elements only. If you consider, for example, if n is 6, 6 minus 1, 5. So 0, 1, 2, 3, 4, 5. If you calculate it, sorry, count it 1, 2, 3, 4, 5, 6, which is nothing but n only, right? Okay, great. So this linear search will take complexity of order of n. Did you clear why it is taking order of 10, sorry, order of n in worst case? Order of n, time complexity. Okay. And what about space? Are we taking any extra space here? Great, Nancy. You already provided the answer for space complexity. Are we taking any extra space here? Apart from inputs, have you took any extra space? No. Even though this int I equal to 0, I mean I is taking, but it is ignorable because it is very, very small, right? So it is constant. Constant will represent it in order of 1. It is nothing but constant. Okay, it is ignorable. So this is my time complexity and space complexity for linear search. Is it clear, everyone? Is this linear search clear to all? Why the name itself saying, I mean, the name itself it is saying you have to linear in the sense you're like this is the way, right? For example, if the elements are there, so you have to once say order of 1 Likita. Okay, sure. Space complexity is nothing but extra, apart from inputs, if you are taking extra space, that will come under space complexity. Did you understand the definition, Likita? So, and here in this linear search, do you think, I mean, uh, did we took any extra space or extra variables or extra arrays or extra matrix uh, to implement this program? Have you taken extra space here? No. Yes. Have you taken extra space, Likita, here? Excuse. Likita, can you respond? Have you taken, I mean, did we take any extra space here to do the linear search to check whether the target is element in our, sorry, found exist in our input or not? So as we didn't take any extra space, it is constant. Okay, got it? Constant will represent it in order of 1. Okay, okay, great. So, so in why we are calling linear searches, you have to go one after another element and you have to do the comparison. Okay, so and you have to go till n-1. In worst case, if the element is doesn't exist or if the element is found at last position. So that's the as we are going one after other like in a linear fashion. So it is called as linear search. So let's quickly do this program. I'll create one class here. Application here. I'll quickly do this program as we already discussed that in the, I mean, this web whiteboard. Array. I have to take the array. So I'll directly initialize it. If you want to take it from user, you can take it using scanner class. What's our array? 8, 5, 1, 2, some 4, 3, 4, 3. So, and I have to give the my target element as well. For example, if the target is 4, let's check for this. And so as it is a linear search, we have to go one by one. It should start from 0 till x and it has to go till n-1. Then each time the n is nothing but size of the array. Okay. So each time we have to check whether our element is equal to our target element or not. If it is exist, we have to print this. Okay, my element is found. And you have to return, you don't I don't return anything, but I don't want to, I mean, the next steps won't be executed. It should come out of the program execution. So I just return nothing there. So after for loop, if my element is not exist, so I have to provide target element doesn't exist. Okay, let's quickly do this. So our target is 4. So it is available in given input. So it should give target element exists. So let's check this. Yes. See here, it is giving target element exists. So let's check for 3. 3 is also exist, so it has to give target element exist. Yes, it is giving the proper output. So I'll check for 100. So 100 doesn't exist in our array, so it should give come out of for loop and it should print this. See here, it's providing proper expected output. Target element doesn't exist. Okay. So this is a linear search. So is it clear, everyone? Is it clear to you all? Okay, great. So we did this for messy room. If it is a messy room, if the elements are not organized, you have to go check one by one only. So this comes under linear search. What if the elements are organized? For example, um, if you see dictionary, if I ask you to search for word, for example, maybe mm, moon. If I give you moon as the word and I ask you to find the where it exactly, in which page number it exactly exists. So what you will do, definitely the dictionary starts from A to Z. It is organized in such a way that it is going from A to Z format, right? Ascending only. So if you, for example, if you have a book and if you open particular page, if particular page is uh, giving P, starts from P. The words are starting from P, which means we have like A, B, C, D, F, G, M, N, O, P, right? So you have to search in previous pages as M is exists before P. So you have to search the previous pages, not the next pages, right? So you will take previous pages. If the previous page is giving N, you can see like M comes after N, sorry, N comes after M, N comes after M only. So you have to check the previous pages. So you will do the iteration till you find M value, and based on that M, you will search for O and then O and N, and you will find this uh, word meaning and the position, right? This is how we usually find it in dictionary. This is it true? I think everyone will do the same thing only. So if we want to do this in in data structures, we'll call it, we have one more searching technique which will take less time complexity. So that is nothing but binary search. So in binary search, the data will be in organized format. So it is nothing but the data will be in sorted order, and you have to I'll give you the target. The input will be in sorted order, and I'll give you the target. You have to find whether this target element is exist in our input or not. Okay. So let us take one example. 1, 2, 3, 4, 8, 5. I'm sorry, 5 and 8, right? It is sorted. So I gave you the input and I ask you to check whether 3 is existed or not. Okay. So like dictionary, you can say like you can check the mid element. What is the middle element here? One, I'll write the indexes. So what is the mid element here? 0, which is nothing but 0 plus 5 by 2. So you will get 2.5, but we always consider 2, right? We'll consider 2 actually here. Okay. So if 2 is my element, second index. So this is the middle element. Is my middle element is equal to target element? Yes, it is equal. So I'll print like it is found. For example, my target is 4 or else 5. Here is this. So this index is 2. Yeah. So I gave you target element as 5. So first I'll consider the middle element only, because once it is organized, so this is my middle element, right? So I'll check, is my middle element is equal to my target element or not. What is my middle index? 2, right? So is middle element 3 is equal to 5? It is not equal to 5, right? 3 is not equal to 5. So, but if you see this, it is not equal to the middle. But as it is in organized manner, like as it is organized in ascending order, I can say like my target is greater than mid, right? Target is greater than mid, right? 5 is greater than 3. Did you agree that? Yes. So once it is, the element is greater than mid value, in which portion I have to check? Consider this is my left portion and this is my right portion, and the elements are in ascending order. On which portion I have to check? Definitely the right portion. So definitely the right portion I'll check. Okay. So what if my target is 1? My middle element is 3, right? Is 3 equal to 1? No, it is not equal. And is target is greater than mid? Like is 1 is greater than 3? No, right? Is not greater than. Is 1 less than 3? Yes, it is less than 3. As it is in ascending order, if you get, if you have to find the element which is less than mid, in which portion you have to search? Left part or right portion? Definitely left portion, right? So, once you, like for example, if the element itself, the middle element, if the target itself mid element, we are not it is like best case, right? You no need to do any operations, further operations. But if the element exists, if the target is greater than mid, you have to search in right portion. But if you consider this, you are neglecting these elements. You are decreasing number of iterations, right? You have to do iterations in this portion itself. You no need to do iterations and you no need to compare this portion. Did you agree that? Did you agree for that? And if my target element is less than mid value, I'll ignore the right portion. I'll ignore the right portion. I'll do the iterations and comparisons in this left portion itself. So if you consider this, we are decreasing the elements. For example, if there are n elements, each time based on the mid value, we are like this is the mid value, and definitely there are n elements. Based on n elements, we are reducing the portions, right? This is the left portion, this is the right portion. And after this, for example, 1, 2, 3, 4, 5, right? 1, 2, 5, and 8. For example, if my element is 1, then my based on this index, or else I'll write the code and then I'll tell you the time complexity better. You could understand it in better. So for this case, what should we have to do? First, as it is in ascending order, like sorted order, and that to ascending order, first we need to get the middle element. And we need to check whether our middle element is equal to target element or not. If it is a target element, I'll print it and I'll return nothing. Okay. If doesn't exist, if the mid element is not target element, but it is less than middle element, I'll check it in left portion. If it is also not the case, if the element is greater than mid value, I'll check it in right portion. Okay. So for this case, I want the mid element, right? So I'll take, or else I'll write left and right. So left should be always 0 initially, right is n minus 1, right? And my what will be my mid value? Definitely left plus right by 2. I think you don't have any quiz today. So left plus right by 2. Let's take this example itself. What is the what is n here? What is n here? How many elements present? 6 elements. So what is left value? Left will be 0 on first iteration. Left will be 0 plus 6 minus 1, 5 by 2. So you have to take 2 only, right? Like it will be 2.5, but we'll take 2 only in as it is an integer. So mid value will be 2. So once you get mid index, you have to check whether that middle element, that particular middle element index, index at that, element at that index is equal to our target or not. If it is found, what you have to do? You just print this out, element was found, and you can return nothing, right? Is it clear this part? Is it clear, everyone? This part? Okay. And the second scenario is your middle element is not equal to target element, but it lies left side portion, which is nothing but our A of mid is, or else our target is, ma'am, we have to consider 2, ma'am. Yeah, we are considering 2 only, right? As it is an integer, this int is mid is nothing but I'll initialize with integer. So as you get floating point, it will take only this portion only, right? So that's case. That's why it is taking 2. We are taking 2. So the second, if the middle element is not target, let's check whether it is lies left portion or not. Left side is nothing but if the target is less than array of mid element. For example, our target is 1, 1 is less than 3, right? At this time, you have to check this portion itself. This is the middle element. So you have to check this portion itself. Initially, my I is this and J is this, right? So, but now you have to ignore these values and you have to compare these. So for that case, I'll initialize J to mid minus 1. Okay. J is nothing but right. Okay. I'll decrement right to mid minus 1 because you have to search from 0 to mid minus 1 only because the element is less than mid value. The element is less than mid value. Okay. But this is also not the scenario. For example, you have 5. 5 is not less than 3, but it is greater than 3. It is greater than middle element. So at this position, at this point of time, you have to search right portion of the array, right? This portion you have to compare. You have to ignore this portion and you have to compare this portion. So for this case, I'll initialize I with mid plus 1. Left portion will comes to mid plus 1. Okay. Is it clear, everyone? And this has to be done till till I is less than or equal to J. While I less than or equal to J. Okay. Why less, I is nothing but left here. So I'm writing the terms of left and right. Left is less than or equal to right. Definitely, why I'm writing left less than or equal to right means, yeah. So you have the portion and you have to check 1, 2, 3. You have to check this position till this position, right? So this is my I mean this is my left and this is my right. You have to compare, I mean each time left or anything will be moved based on that, or else I will draw the dry run. Okay. So at first, for example, we have this array. I will rewrite it 1, 2, 3, 4, 5, 8, and you have to find the target element is 5. Okay. So here at first the left is 0 and the right is n minus 1. What is right here? How many elements are there? 1, 2, 3, 4, 5, 6. So n minus 1 is nothing but 5, right? 6 minus 1, 5. So here, what is our condition? Is 0 less than or equal to 5? Is 0 less than or equal to 5? This is the iteration 1. Yes, it is less than. So it will comes into while loop. Here what we wrote, mid equal to left plus right by 2. 0 plus 5 by 2, 2.5, and as it is integer, it will hold 2 only. So here we are checking, is a of mid equal to target. What is a of mid? A of 2 equal to 5. What is a of 2 here? Second index, what we have? Right index is 3, right? We have at second index, we have 3, element 3. So 3 equal to 5. It is not true. 3 is not equal to 5. So it will comes into next else if block. Here what we have written is target less than a of mid. Is 5 less than a of 2? Is 5 less than 3? Is it true or false? It is false. It is not less than. So it won't execute this else if. I mean, it won't comes into this else if block. So then it will check the next else if. Here what we have written is target greater than our mid, a of mid. Is target greater than mid, 5 greater than 3? Is it true or false? It is true. 5 is greater than 3, right? So at this point of time, you know your element lies right side of the position. This position, it is, as the element is greater than mid, definitely it will lies in this portion. So instead of left here, I have to check this portion itself. So my left should start from mid plus. Sorry for getting any noise. So left should be mid plus 1. Okay. So here we wrote the same thing. Left equal to mid plus 1. What previously what is our mid? 2, right? Now mid plus 1. Left equal to 3. Okay. Did you understand this first iteration? Any doubts? Any doubts? Okay, clear. So on the second iteration is my left. What is my left now? 3, right? Is 3 less than or equal to right? My right is still 5, n minus 1 only. Is 3 less than or equal to 5? Yes, it is less than. So now we have to calculate mid again. Left plus right by 2. What is my left? 3. 3 plus 5 by 2. 8 by 2, 4. So mid value will be 4. So now we'll check whether a of 4 is a of mid is equal to target. So what is a of 4 here? Fourth index, we have 5, right? So is 5 equal to 5? Yes, it is true. It is equal. So we'll print this out here and we'll return nothing. So it will stop the program execution here itself. So did you understand why it is happening and why we are checking left, giving left less than or equal to right? Each time you have to compare from that particular portion itself. So definitely your left should lies less than or equal to right only always, whether it is a left portion or a right portion, whether it is a left portion. If it is a left portion, your left should lies here, right should lies here. If it is a right portion, sorry, actually left is this one only. So if it is a right portion, definitely the left should lies here and right should lies here only. It won't cross. If it is crossing, it's senseless, right? It is meaningless. So is it clear, everyone, this binary search program? Or any doubts? as we are having organized data, like the data is in sorted order. So that's the reason we are reducing the iterations based on the mid value. If my mid value is our target, I'll stop there itself. But if it is less than mid value, I'll search it in left side portion and I'll ignore right side portion. Or else, if the target lies, if the target is greater than my mid value, I'll search it in right portion and I'll ignore left portion. That's it. It's like dictionary only. Searching in dictionary. Is it clear, everyone, or any doubts? I need more responses. Clear? Okay. So each time what we are doing, we have n elements, but each time based on the mid value, you are dividing left portion and then right portion, right? And again here you will divide portions because in this program, in this iteration itself, first you get the mid value and you understood that it lies in right position. And this right position itself, you are checking the mid value, and based on that mid value, you are doing the iterations, right? For example, if the target is 4, definitely it is greater than mid value, so you have to do the iterations on the right side portion only. But here you will get the mid value as 5 is not equal to 4, but this target is lies less than to this mid value, so it will lies left side portion. So right will be mid minus 1, which is nothing but 4 minus 1 3. Did you get it? So each time we are reducing the portions based on the mid value. Did you understand why I'm writing n and n by 2 and n by 2? Is it clear? Okay. Mayur, you have raised the hand. If you have any doubt, you can ping ping it in the chat. So if there are again, if the element, like for example, if you have like 100 plus elements and each time you are based on the mid value, you are dividing. Here itself we will divide n by 8 based on the mid value. So each time you are reducing the elements, right? You are reducing the elements. Till at which point you will stop? Till you get the mid element, which is nothing but till you get the only single element. Did you agree this? You have to do the iterations till you get the mid value. Mid value which is nothing but only single element you will get, right? So, and you doesn't know how many, once more, okay, sure. So you have n elements, okay? Based on the mid value, you are segregating left portion and right portion. Let's assume there are 6 elements and or else 7 elements. Your mid element is 2.5. So there will be 3 elements here, 3 elements here. This is, left portion will contain 3 elements, right portion will contain 3 elements, and mid is 1 element. Is it clear, Nancy, till here? So which is nothing but n by 2 and n by 2. I'm writing it. So again, this portion based on the index, I'll do the left portion and right portion. Mid value will be 1. So left side will contain only single element, right side will contain single element, similar to in the right portion as well, which is nothing but n by 4 and n by 4. Like dividing equal parts, right? N by 2 by 2, n by 4 only. So n by 4, n by 4. So if there are for this you have only 6 elements. If there are 100 plus or n elements, each time how you will segregate is each time you will segregate like half of positions, so half parts only. N by 2, n by 2. So if you see this n by 4 plus, n by 4 plus, n by 4 plus n by 4, which is nothing but 4n by 4. 4 will get cancelled and there are n elements only. You are segregating n elements into equal parts. In left position, again it is left position will contain left and right position will contain left and right. And each portion contains n by 4. Is it clear, Nancy? And again here, based on the mid value, we'll segregate the data to two halves, left and right. Is it clear, Nancy? Not only Nancy, others as well. So you have to do n levels. You doesn't know n in how many levels it will take, but you will end up with single element. Till you get that middle element, single element, you will do this iterations. I mean, you will segregate the data into left portion and right portion, right? Till you find the single element. So which is nothing but here n by 2. Can I say like n here n, right? So can I say n by 2 power 0? 2 power 0 is nothing but n by 1 only. So n only. So can I say here it is 2 power 1? Can I say here it is nothing but n by 2 square? And here n by 2 cube. Can I say this? N by 2 cube is nothing but n by 8. Can I say this? Yes. So, and you doesn't know how many levels it will take. Let's assume it is taking k levels. I mean, it is segregating the data till k levels. At kth level, you will get single element, that mid element. Okay. So, if there are k levels, can I say n by 2 power k? If there are n by k, and n by k levels, n by 2. Yeah. So, n by 2 power k. So, which is equal to single element. At n by 2 power k level, you will definitely get only one element, right? So n by 2 power k equal to 1. Is it clear? This part, it's like mathematics only. Yes. Okay. So I use n equal to, and here 1 into 2 power k. So which is nothing but 2 power k only, right? So here I use log. I'll apply log both sides. Log. So log 2 power k. If you know the mathematics, log 2 base 2 is always 1. Okay. So here log 2 log usually comes with base 2 only. So log 2 base 2 is 1. So k. I mean, you can ignore that and it will be k only. Did you understand this part, or do you want me to explain one more time why n by 2 power k levels and why we are assigning it to 1? So we have k levels, k steps. K levels are nothing but k steps. It is taking k steps to execute binary search. Can we say this? It is taking k levels to execute this search. K level is nothing but log n steps only. Log n steps. So it is the number of steps it is taking is order of log n steps only. Did you understand why the time complexity is order of log n in binary search? Each time you are ignoring one portion of the element, like maybe right portion or left portion, depends upon the target. So that's the reason it is order of log n. Is it clear, everyone? I need more responses. Is it clear, or any doubts? Yes, Nancy, is it clear? I could see few S and clear pings here. What about you, Nancy? You provided ma'am. Sorry, you pinged ma'am only. Only for binary we used to get this. I didn't get you actually. I'll tell you. So is time complexity part clear to you, Nancy? Not only Nancy, others as well. Is this part clear why it is taking order of log n times? Okay. So what is our space complexity? Are we taking any extra space here in this program? Are we taking any extra space? No, as we are not taking extra space, what will be my space complexity? It's constant. So order of one, right? So in linear search, if you compare, excuse me, are you getting any background noise from my side? No, great. Some announcements are going on actually here. Okay. So in linear search, it is order of n. The space complexity is order of 1. In binary search, it is taking just logarithmic time. It is very less compared to n, right? So which one is efficient? Which one is optimized way to search the element or target? Definitely binary search. But the binary search criteria is you can search it in if the elements are in sorted order. Remember this. So if you have given like if the input is not in sorted order, better to use linear search only. Okay. If the elements are not in sorted order, better to use linear search. If it is in sorted order, use binary search. Okay. Is it clear, everyone? Okay, great. So let's quickly do this binary search program and we'll proceed for sorting algorithms. So I'll take the array from here itself. So I'll give the target and the array should be sorted. 1, 2, 3, 4, 5, 8. Okay. So I'll give the target as 5 and I'm checking. And initially the left should be 0 and the right, oh, sorry, and right part should be n minus 1. And we have to iterate till left is less than or equal to right. It shouldn't cross, both left and right shouldn't cross. So that's the reason we are putting this condition. And each time we have to check the mid value, which is nothing but left place right by 2. And here, after you find the mid value, you have to check whether our mid value is equal to our target or not. If it is yes, I'll print target was found and I'll return nothing to stop the program execution. So if it is the best case if the element finds is at the middle. But what if the element doesn't exist in mid? Let's check whether our target is less than our a of mid value. If it is less than, we have to check it in left position. So our right should point out to mid minus 1. Or else if it is also not the case, if the target is greater than a of mid, definitely we have to search it in left portion. So the left portion will be, we have to move our left to, the first element in the right portion, which is nothing but mid plus 1. So we have to do till left is less than or equal to right. So after this, if you didn't find any element, you have to say, hey, the element doesn't exist in given input. Okay, is it clear? We already discussed this, right? And let's quickly do the, yes. I run this and fifth was, sorry, but I gave target as 5 and 5 is already existed. So it is giving target found. If I give 10 here, the target is not exist in the given input, right? So it has to print not found. So it is giving the correct expected output. Target element is not found. Is it clear, everyone? Or any doubts? If you want, I'll provide this 1 minute. Yeah, sorry. Yeah, I share this code snippet if you want. I'll share this in chat box. Okay. So is it clear, everyone? The searching part, the linear search, binary search, can you uh, do the programs if I give you the output, or else I'll ask you. I gave you these elements. Which searching technique you will use, linear search or binary search? And the target, I give you one target element. I need more responses, only Haripriya is responding. If I give you this input, this array and target, which technique you will prefer, linear search or binary search? Why, Soumya? Why binary search? It is not in sorted order, right? Better to use linear only. So I gave you one more array and I gave you the target. Which searching technique you will use? Observe the input and tell me the technique. Yes, definitely the binary search. Great, because it will take less number of times and it is optimized solution. Optimized solution. Yes, great. So this is about searching techniques. We have linear search and binary search. We discussed about the searching and we discussed about the program and time complexity and space complexity as well. So let's quickly take 5 minutes break. Come at 12:06. We'll discuss about sorting techniques. I'm not sure how many sorting techniques we'll cover in this today's session, but we'll try as much as possible. If there are any pending topics, we'll discuss in next week as well. So yeah, come at 12:06 exactly. We'll discuss about sorting techniques. Yeah. Is everyone back? It's already 12:06. Can we proceed on sorting techniques? Great. I need more responses. Is everyone back? Okay, great. So we'll discuss about sorting techniques. What is sorting actually? Do you know what is sorting? If it is, just give me the meaning or definition. Yes, arranging the elements in interdependent or dependent order. Sorry. So sorting is nothing but arranging the elements, either in ascending or descending order, right? So there are different sorting techniques available in data structures. So few are like there are many categories we'll say. Um, on time complexity wise, I'll say do the segregation of the sorting techniques. So by time complexity, order of n square and order of n log n. That's it actually. Yeah, we don't have counting. Yeah. So order of n square and order of n log n. So here we'll be having bubble sort selection sort, and insertion sort. Okay. So all these sorting techniques will take time complexity of order of n square and space complexity of order of 1. And this order of n log n will be having merge sort and quick sort. These are the best sorting techniques. Usually, yesterday we discussed about arrays.sort method, right? It will internally sort the arrays. So all the inbuilt functionalities either use merge sort or quick sort because order of n log n is optimized one compared to order of n square. Okay. So based on this, we are having sortings, and few people will say, I mean, they categorize the sorting in like in place, not in place. In place is nothing but don't take extra space. It won't take extra space. And not in place will take mass sort will take space complexity of order of n. If you take extra space, it is like not in place. Okay. These are like the categories, and they'll categorize in counting as well. Like if I say in place, not in place, counting. So in place is nothing but which doesn't require extra space. Here bubble sort, selection, insertion will comes to the picture. And not in place, merge sort and quick sort because this will take extra space. Okay. So counting, and based on the counting, we have two more sorting techniques. One is radix sort. Based on the buckets, it will sort the elements, and another is counting sort itself, the name itself, counting sort. So in today's class, we'll discuss more on in-place sortings, bubble selection and insertion. But remember, among all these sorting techniques, merge sort and quick sort are the best sorting techniques because it will take very less number of steps. Order of n log n is time complexity. Okay. So all the inbuilt sorting techniques will use either merge sort or quick sort. Okay. So in today's session, we'll discuss about bubble selection and insertion sort. So is it clear the what do you say the types of sortings? Okay. So let's focus on bubble sort first. Uh, so you will be having array. I'm taking same array. Okay. And you have to sort the array. So the output should be 1, 2, 3, 4, 5, and 8. 8. Sorry. So the output should be 1, 2, 3, 4, 5, 8. Okay. So in bubble sort, what will happen is we'll compare the adjacent elements and we'll do the swapping. Okay. On first iteration one, let's do manually. 8, 5, 1, 2, 4, 3. So this element and this element are adjacent, right? So we'll do the comparison. Is this element greater than this element? Yes, it is greater than. So I'll do the swapping. Okay. So on the second time, in the iteration itself, we still have few adjacent elements to compare. So now 8 and 1 we have to compare. Is 8 greater than 1? Yes, it is greater than. So I'll do the swapping. And after this, we still have few adjacent elements to compare. So is 8 greater than 2? Yes, it is greater than. So we need to do swapping. After that, we still have few elements to compare. Is 8 greater than 4? Yes, it is greater. We need to do the swapping. So we still have one more adjacent element to compare. Is 8 greater than 3? Yes, it is greater than 3. So we need to swap, right? Is it clear the iteration, ma'am? Okay. Now the second iteration. So on the second iteration, like we have 5, 1, 2, 4, 3, 8, right? So again, we need to compare adjacent elements. Now my adjacent elements are these. Is 5 greater than 1? Yes, it is greater than. So I have to swap. I swapped 1 and 5. So we still have few more elements to compare. Is 5 greater than 2? Yes, it is greater. So we need to do the swapping. So again, we still have few adjacent elements to compare. So 5 greater than 4? Yes, it is greater. So we need to do the swapping. 1, 2, 4, and we still have few comparisons to do. So is 5 greater than 3? Yes, it is greater than. So we need to do the comparison. We still have one more comparison here, and but it is already like we no need to do any swappings because 5 is not greater than this 8, right? So it's 5 and 8 only. Okay. Is iteration took clear to everyone? Is it clear? On the iteration 3, 1, 2, 4, 3, 5, 8, right? So again, we need to compare the adjacent elements, and based on that, we need to do the comparison. Sorry, swap the elements. So is 1 greater than 2? No, it is not greater than. So it will be same. No need to do any swappings. But we still have few adjacent elements to compare. Is 2 greater than 4? No, it is not greater than. So no need to do any swappings. But still we have few adjacent elements to compare. Is 4 greater than 3? Yes, it is greater than. So we need to do the swapping. So but still we have few more comparisons. But if you see this, is 4 greater than 5? No, it is not greater than. So no need to do any swappings. Okay. But we still have few comparisons. Is 5 greater than 8? No, it is not greater than, right? So we no need to do any swappings here. Okay. So on iteration 4 and iteration 4, you have 1, 2, 3, 4, 5, 8. Now you will compare 1 and 2. Is my 1 and 2 greater than, sorry, 1 is greater than 2? No, it is not greater than. So no need to do swap anything. So then I'll compare 2 and 3. Is 2 greater than 3? No, it is not greater. So I'll do no need to do any swapping. Is my 3 greater than 4? No, no need to do any swapping. After that, 4 is greater than 5? No, it is not greater than. So no need to do any swapping. Is my 5 greater than 8? It is not greater than. So no need to do any comparison. So as we are not no need to do any comparisons, you can say it is in sorted order. So if you observe this, our output is this one only, right? So did you understand the bubble sort? On each iteration, you need to compare the adjacent elements. And if the previous if the previous element is greater than the next element, you need to do the swappings. So you need to do these iterations till your array is sorted. Is it clear, everyone, the bubble sort? Is it clear to you all? Okay. If you are clear, observe the pattern in bubble sort. On first iteration, you ended up with this. On the second iteration, you ended up this. On the third iteration, you ended up with this. On this next iteration, you ended up with this. Did you observe any pattern? Yes. So in bubble sort, when you are iterating on each iteration, the maximum element will get placed at its right position. Okay. The highest element will find its correct position or will place in right correct position. So what is the highest, I mean, on iteration 1, what is the highest element among the given input? 8 is the highest. So 8 find its correct placed in correct position. So after 8 on second iteration, what is the next highest element? 5. So 5 placed in its correct position. After that, 4. 4 placed in its next position. So we have to do n minus 1 iterations. So on each iteration, the highest element will get find its correct position. This is the bubble sort. Okay. Is it clear to you all? Next. Okay, let's do the coding now. So if you see this, we are on each iteration, we are comparing the adjacent elements, and based on that, we are doing the swapping, right? So for that case, I use one for loop. I'll start with 0 index to, I have to go till n minus 1 index till last value. So each time my j should be incremented. And here, what should I have to check? I have to check adjacent elements. Excuse me. So which is nothing but I have to check a of j is less than a of j plus 10. Sorry, you have to check greater. A of j is greater. If it is greater, we have to do the swapping. I think more any all of you know how to swap the elements. So you can take the one temporary variable and you can do the swapping. Right? This part is swapping. So is it clear, everyone? But yeah, as you are using j plus 1, if my j is n minus 1, what will happen? N minus 1 plus 1. It will be n. We'll get array index out of bounded. So for that case, we have to go till n minus 1 only. Not, I mean like n minus 2 position only. Is it clear to you all? Is it clear, this part? Okay. So this is we wrote the for loop for this to check these adjacent elements. But how many times we have to do this iteration? N minus 1 times, because see here, this is iteration 1. Next iteration 2. Next iteration 3. We have to go till n minus 1. Okay. So for that case, I'll mention this entire code snippet inside another loop. Is it clear, everyone? This is for each iteration. This iteration 1. On this iteration itself, we are doing something. We are checking all the adjacent elements and comparing. So for that case, we are using J loop for this comparison and do this swapping. Is this code snippet clear to you all, or any doubts? Clear? Okay, if it is clear, what is the time complexity in worst case? What is the time complexity? You have two loops, not a single loop. You have two loops. Yes, Soumya, you're correct. We already discussed, I think, I'm not sure whether we discussed. Yeah, here itself we discussed if there are two loops, it will be like if there are n and n, n square. If m and n, m into n, right? So, yeah. So the time complexity will be order of n square. What about the space? Have you taken any extra space for bubble saw? Did you took any extra space here? No. Even though you took temp, it's just a constant only, single one only. So order of one only. Okay. Is this part clear? If it is clear, we'll go ahead and execute it. Okay, let's quickly do this part. So I'll take this array. So I'm directly writing two loops. One is for iterate. Uh, we have to iterate till n-1. We need to do n-1 iterations in bubble sort. On each iteration, you have to do the comparison for all the elements. So if and on each we need to do the comparison for adjacent element. For that case, I will check whether a of c is greater than a of z plus 1. So if it is greater, we need to do the swapping. So let's try that swapping logic here. So at last, I have to print the sorted array. So instead of loops, I'll use some inbuilt function to print the arrays. So which is nothing but arrays dot toString method. And we have to pass array value variable here. So is it clear, everyone? So I'll run this. See here, it is giving expected output. It is organized, sorry, do the sorting in ascending order. Okay. So what if I want to do the order in descending way? Like I want the order like 8, 5, 4, 3, 2, 1. Which part of code I have to modify? Yes, we have to change the if condition. Instead of greater, we have to use less than. Yes, it is giving 8, 5, 4, 3, 2, 1 descending order. Okay. Is this part clear to you all? The bubble sort. Okay. If it is clear, then we'll go ahead and check for selection sort. And in bubble sort, the name itself same. Like if you throw stone into any river or any inside the bottle or anything, it will form these waves, right? Right. So the largest wave will be at the last position, and the smallest one will, the smallest one which contains small circumference will be at first, right? So it is nothing but forms in bubble way. So that's the reason the name came. Based on it, the largest circle, the circle with largest circumference will be at last position. Okay. So the selection sort. The selection sort is very, very easy one. I'll give you the array. I'm taking same array 5, 1, 2, 4, 3. And you have to give the output in sorted manner like 1, 2, 3, 4, 5, 8 only. But in selection, in bubble sort, you will do on each iteration, you have to do the comparisons to the adjacent elements and you need to do the swapping, right? But in selection sort, we'll go by index by index. For example, I'll write the indexes here. So at 0th index, I'll find the minimum element. So what is the minimum element among these elements? What is the minimum element on the iteration one? On the iteration one, yes. On the iteration one, At this one, I mean, at first position, 1 is my minimum. So I'll place 1 here. Okay. I'll swap this value with this value. On the iteration 2, the 0th index is already filled. So we have to focus on the next index, 0, 1, 2. Yep. On the this index is already inserted, like we already placed the minimum element. So we need to get the minimum element among these elements, right? From first index to fifth index. What is the minimum element? Second minimum element among these two. So I'll place the element here and I'll do this. Okay. Excuse me. So on the third iteration, these two are already sorted. So I need to focus on this part. So what is the next minimum element? 3. So I'll place 3 here. On the next iteration, what is the minimum element? These 3 are already sorted. What is the minimum element among these? 4. So I'll sort. Again on fifth iteration, 1, 2, 3, 4 is already completed. You need to get the minimum element. 5 is already at the minimum element, so no need of swapping. So this is how you have to do. Is it clear? The selection sort is very simple one. So I will go by index and we'll place the minimum elements. Or else in simple words, we'll place the correct element based on the index, or you can say at the correct index, at correct position. Okay, is it clear the selection sort, everyone? Do you want me to take any other example and you want me to explain that? Clear? Great. Okay, great. So if you see this, we are doing some iterations. On each iteration, we are finding out the minimum element and we are swapping that element to that index, right? So anywhere I need one loop to do all the iterations. I need to do n-1 iterations. So on each iteration, I have to find the minimum index. First, I take minimum index as this index itself. Excuse me, I itself. So now I will check in the remaining positions. So J should be start from I plus 1. I'll tell you why it will like that. Because if you see here, if you on the first iteration, the first minimum element will get placed in a right position. So you no need to focus on this part. You need to focus on this next part and you have to get the minimum element. So it should be I plus 1 till n minus 1, right? After second iteration, the two elements will get placed. So after that, the I should start from this value. Sorry, you need to focus on the next remaining elements and you have to get the minimum element, right? So that's the reason I'm giving J equal to I plus 1, J less than or equal to n minus 1, J plus plus. Is this part clear? Is this two loops clear to you, everyone? Okay. On each iteration, what we are checking, we are trying to get the minimum value, right? So I do if A of minimum index is greater than A of say, definitely this A is not the minimum index, right? The minimum index should be J now, right? For example, if I have 1, 8, 5, 3, 2, 7, 9 here. So you have to do the comparisons with this element with all the elements. I mean, you need to do comparisons for all the elements actually. So if you do the comparison, is which is less than is 0, 1, 2, 3, these are the indexes. Yes, is 9 greater than. Okay. So my minimum index is at start, the minimum index is 0. So is my A of 0 greater than 8? Is 9 greater than 8? Yes, it is greater. If it is greater, it is not a minimum value. It is the minimum value. So I'll assign this index value to this. The index is nothing but 1, right? So 1. So after this, I'll do the comparison for this. This is 1 minute. So, yeah, is 8 greater than 5? This is the minimum index now, right? So, is 8 greater than 5? Yes, it is greater. So, it is not a minimum index. So, the minimum index is this index, I mean, where it is holding 5 value. So, the index is 2. So, now the min index is this one, 5. Is 5 greater than 4? Yes, it is greater. So, it is not my minimum index. The minimum index should be this index, which is holding 4 value. So, minimum index will be 3. So, after this, the next iterations like is minimum index is the greater than a of z, like is my 4 greater than 3? Yes, it is greater. So it is not a minimum index. Sorry, it is not a minimum index. The new minimum index should be 4, which is holding 3 value. So after that, 3 greater than 2, yes, it is greater. So it is not a minimum index. So my minimum index is 5, which is holding 2 value. Did you understand this part? We are just checking. Is my voice clear to you all? Is it clear? Okay. I'm getting like a notification that your network bandwidth is low. So this part is used to get the minimum index among the elements. Okay. At first time, you have to check for 0th index to n minus 1. But on the next time, you have to check for I plus 1 to n minus 1. On the next time, you have to check the next part. On the next time, you have to check the remaining part. So the flows goes in that way. That's why we are comparing for, we initialize j with I plus 1. Is it clear, everyone, this part? So once you get the minimum index, what you have to do? You have to put that minimum index value at that position. If it is first iteration or 0th iteration, you have to place the first minimum value. If it is the next iteration, you have to place next minimum value. Is it clear, everyone? Is this part clear or any doubts? I need more responses. What about others? Only Haripriya responded. Is everyone there in the class? Is it clear or any doubts? I didn't see any responses. Is it clear or any doubts? If you have any doubts, let me know. I'll re-explain this. Clear? Okay, I could see two responses. What about others? What about you, Likita, Pranjali, Soumya? Is it clear? Okay, great. So, if it is clear, tell me the time complexity and space what is the time complexity? Last line? Okay, the last line is nothing but on each iteration you have to get the minimum element. The first minimum element will be placed at first position. Did you agree that, Nancy? So on the second iteration, the second minimum element will get at second position. So here we are getting the minimum index, and we are on each iteration we are placing that minimum, that minimum value. That's it. Is it clear? Okay, great. So if it is clear, what is the time complexity for selection sort? Yes, we are having two loops, and each time we'll go, like it will take order of n, and it will also go till order of n into n, order of n square. And did we take any extra space here? Have we taken any extra space? We took minimum index, but it is still ignorable. It is a constant. So order of 1. So is this part clear, the selection sort? If it is clear, we'll go ahead and do this. Okay, let's quickly do this. So I'll take the same array. So I'll quickly do the execution. So far, we need n-1 iterations. And each iteration, I'll treat that I as the minimum index. So which is easy to compare if I have something. So I have to iterate from I plus 1 till z less than or equal to n-1 and g plus plus. So each time I have to get the minimum element. So I'll check whether a of minimum index is greater than a of z. If it is greater, so it is not a minimum index. So I have to map the minimum index with new value. So I'm mapping that. So after this loop, I'll get the minimum index. So I have to place that at the ith position. So I'm writing that logic. One minute. Sorry. So this is after this we have to print the sorted array. So I'll execute it. Let's check. 1 minute. Something else. Missed. Yeah. Yes, we need to do swapping. Here we need to do the swapping. In temp equal to a of I'll quickly do this, or else a of 5 and a of min index equal to 10. So I did this swapping here. So let's check this. Yes, it is giving proper expected output if you say this. So is it clear, everyone? Is this part clear? Okay, if it is clear, I want to sort it in ascending order. Descending order, 8, 5, 4, 3, 2, 1. So which portion of the code I have to modify? So if we want to do the selection sort in descending order, we need to get the maximum element instead of minimum element, right? So for that case, I'll take max index and I'll check whether my max is less than a of 5. If it is less than, I'll initialize max with no new value and I'll do the swapping. So let's check this one. So if you see this, it was sorted in descending order, right? Hope is it clear? Sorry, Hope everything is clear to you all. Can we proceed for insertion sort? Okay, great. So the insertion sort is nothing but, let's take the same array, take 5, 1, 2, 4, 3. So and our output should be 1, 2, 3, 4, 5, 8. So on insertion sort, like I'll tell you using iterations so that you could understand. So on the first iteration, I'll take the first element. Okay. We still have these elements, but I'll consider only the first element. Make it consider it as key element. So or else you can assume like it is visible and these elements are not visible. Okay, on the first iteration. So as we have only one element, this one element itself is in sorted order, right? So on the iteration 2, what I'll do is I'll add one more element from not visible part. We still have these elements in the same array, but to understand it better way, I'm just saying visible and non-visible. So I'll add one more element to the visible part. Okay. And I'll do the comparison for this and I'll place the correct, I'll place the element in its correct position. So this is the correct position, right? 5 and 8. These are visible, these are invisible, assume. Okay. So on the iteration 3, I'll add one more element from non-visible part. So what will be my key value? My key will be 1, but I need to, and remaining elements, invisible elements will be 2 and 3. But while you are adding itself, you have to do the comparison. Is it, we need to make sure the element is added at correct position. So we need to do the comparison. Is 8 greater than 1? Yes, it is greater. So we need to do the comparisons. And we have to swap. And then we need to do comparison for 5 and 8. And we have to do like this. Okay. So on the next iteration, I think iteration 4, you have to add 2 from the non-visible part to visible part. And you have to put it in its correct position. I'm directly writing like this. Save the time. So on the iteration 5, my key element, the new element added should be 3. So nothing left in invisible part. So we have to place this new element in its correct position in this visible part. Okay. If you see this, it is in sorted order. I think I missed out 4, 8. Okay. So in insertion sort, what we can say is on each iteration, add element, and you have to make sure that element placed in correct position. Okay. Is this part clear? Is this definition clear to you all? In each iteration, you have to add elements, and we have to make sure whether that element is in added it correct position or not. So here 8 is just a single number, so no, it's in correct position. So while you are adding 5, you need to do the comparisons and you have to place this new element, this key element in its correct position. So it's in sorted order now. So after that, 1 should be added. 1 is the key element, but you have to make sure at which position you have to place 1. So on doing comparisons, you will get to know 1 should be placed at first position. So you have to place that. After that 2, after that 3. Okay. So that's the reason the name itself, insertion. While inserting an element, make sure that element placed in its correct position. Is it clear, everyone? Give me a minute. Sorry. Is my voice clear now? Is it audible? Okay, great. I'm having a bad throat pain actually, so I took time to drink some water. Yeah. So let's do the program implementation now. So you have to do iterations till n minus 1, right? So anyway, we know we need some loop to iterate till from 0 to n minus 1, right? So this part is clear. But on each iteration, what we are trying to do, we are adding some element, some key element into the visible part. So for that case, I'll take my key element as, or else I'll start, if you see this, at zeroth, I mean first iteration, as we are having only single element, this itself is in sorted order, right? We can ignore this case. So we can start from this iteration. Did you agree that? On the first iteration, we'll definitely have the first element. And as we are having single element, it's already in sorted order. So let's go ahead and check from this element, this part, first position. Okay. So instead of 0, I'll start from 1. Okay. So I'll add this element. As we are dealing with insertion sort, each time we have to insert new element. So while inserting, while you are taking the element, while you are adding, we need to make sure at which position we have to place that value. We have to place that element, right? So at first, you are have like 8 and then 5. So as you are ignoring the first iteration, 0th iteration, as we are having only single element, on the second iteration, the key is a of 1. A of 1 is nothing but 5, right? This is the a of 1. So while inserting it, like before inserting it, we need to check its correct position. We need to do the comparisons and we need to check, we need to place it in its correct position. So for that case, if it is a 1, only we need to check with 0, right? 0th element, the previous element. We don't have any other elements, right? So I'll take j value as I minus 1. Is it clear why I'm taking I minus 1? Okay. So for this case, as you are having only 2 elements, you can say like if z is greater than 0 and my z is, and while before inserting itself, we need to make sure its correct position. So I'll check this. For example, if 5 and 8 are already sorted, if 1 is coming, 1 is the key element definitely. So we have to do the comparisons till j. For example, here j is there. So you need to compare this value with one value and you need to compare this value with this value. And then only you could understand, okay, it is less than 5 and 8. So you have to place before this 5 and 8, right? Did you understand why I am looping over till j greater than or equal to 0? Is it clear or do you want me to explain one more time? Okay, so we have to do comparisons while j is greater than 0. But while doing iterations itself, we need to check whether it is greater than or not. If it is greater than, then only you have to do the swapping, right? Or else no need. So the swapping also will take like a of j equal to a of j plus 1. Okay. Or else I think sorry. Or j, if it is greater, j plus 1. J plus 1 with a of z. Because 5, 8 and 1 is coming. This is my key value. So this is j, like j will be as 1, like I will be 1 minute, where is 1? I need to find, yeah, 0. I do the indexes quickly. So I will be 2. So my j will be I minus 1. So nothing but 1. 2 minus 1, 1. So we need to check these two elements with this element. Like we need to check these two elements with this element, and based on that, you have to do the swapping. So first, j will be 1. So is 1 greater than or equal to 0? Yes, it is greater than. So I'll check whether my j is greater than key or not. Is my 8 is greater than 1? A of j is nothing but 8, right? A of 1 is nothing. Is 8 greater than 1? Yes, it is greater than. So you have to swap these elements first. Sorry, 5. A of j plus 1 equal to A of z. Think, yeah. 5 and 5. Yeah, each time j should be decrement 1 minute. A of j plus 1 is nothing but A of 2. A of 2 will place with 8 only. Okay. Yeah, you need to. Yeah, A of j plus 1 is nothing but. Sorry, j plus 1 is nothing but A of 2, right? We have j equal to 1. So j plus 1 equals to A of z. So you need to place this 8 at second position. So you will be having like this. Did you understand? You are just moving element to next position. Is it clear? Or do you want me to explain again? Clear? Okay. So after that, my j should be decremented. So my j is decremented. Now my j value is 1. Sorry, 0. 1. What happened? It's not taking. Yeah, I'll explain again. Not sure why it's happened. I'll reload it. My voice and video is clear, right? It's taking some time to load, that's why I'm asking. Okay. It is taking time. Else I'll open Jamboard. Okay, or else I'll open Notepad and explain this. So 8, 5, 1, 2, 4, 3. Yeah. Yeah. So on first iteration, so 8 will be added. So I'll skip that iteration. I'll start from next iteration. So I'll compare this. Okay. Because 8 will be already in sorted order. So I'm taking my key as 5. Okay. So after taking 5, I already have 8 here. I'm trying to add 5. So before adding itself, I'll compare and I'll do the comparisons and we'll find out at which position I have to add 5, before 8 or after 8. I'll do that and then. Okay. So, not this. Okay. So at on the first iteration 1, let me quickly do it. what is my key? It is nothing but a of 1, right? Which is nothing but 5. Okay. So before adding key, I have to make sure at which position I have to add 5, before 8 or after 8. So for that case, I have I mean, as we are adding only one element, before that we have only single element, so I'm using I minus 1. So it will be 0, 1 minus 1, 0. So here the condition is 0 greater than or equal to 0 or not? It is true, right? 0 is equal to 0. So it is true. So here itself I'll check whether that already existed element is greater than key or not. So we are already having 8 here. We are trying to add 5. So we are finding out at which position I have to add 5, before or after. So is 8 greater than 5? Pranjali, is 8 greater than 5? It is greater than, right? Yes. So as it is greater than 8, so what I'll do is, we have only single block, single visible block. So I'll add extra block as we are trying to add new element. I'll place 8 here from this, because 8 is greater than 5. So I'll place 8 here. So for that case, a of j plus 1, which is nothing but adding one more block, right? At that block, we have to copy this element itself, a of j element itself. Is it clear, Mansi? Sorry, not Nancy, Pranjali. Okay, but this position is empty. You place this value 8, right? But this position you have to fill the value. So for that case, what I'll do is, I'll do a of j equal to my key value. A of j is nothing but 0 right now, this position. So key is nothing but 5. So I'll add 5. Is it clear, Pranjali, now, or do you want me to explain with another iteration? Like each time we are adding blocks actually. So if you already have 5 and 8, while you are trying to add 1 itself, you have to check at which position you have to add. So I'll check 8 is 8 greater than 1. Yes, it is greater than. So I'll move 8 to this block. We still have like this only. So I don't want to confuse you. So I'm just using empty here. So after that, we still have j value here. So is 5 greater than 1? Yes, it is greater. So I'll move 5 to this position. This position. After that, j will be empty only. Like if this condition won't be, it will be minus 1. So a of j should be key value. What's the key value? 1. Yeah, it's for loop, while loop only. Yes, it will be while loop, not if condition. Sorry, my bad. It's while loop only. Is this part clear? Okay. So this is how you have to do. So once you are done with 3 elements, if you are getting one more element, what you will do? For example, 1, 5, 8, and you are trying to add 2. So you will compare 8 with 2. So is it greater or smaller? It is greater. So I'll move 8 to this place. After that, I'll check 5 and 2. Is a of j greater than key? Yes, it is greater. So I'll move my 5 to this place. Okay. So after that, we have 1. Is 1 greater than 2? No, it is not greater than. So it won't go that inside the while loop. So you have to place 2 here. Okay. Is it clear, everyone, the insertion sort? Is it clear, everyone? You have to take each time, you have to, you need to do the iterations, and while adding itself, before adding itself, you have to make sure at which position I have to add that element. So for that case, we are using one loop for iterations and one loop while loop to check to do the comparisons. Okay. So if it is clear, what is the time complexity here? We are also following. This is the one. Yes, it will be order of n square only. because the outer for loop will take order of n times, and again this loop will take order of n times only. Because if uh, if all the elements are there like 1, 2, 8 and 5, if you are trying to add 3, you need to do comparisons for all the elements, right? So that's the reason it will take n steps. So n into n, order of n square. And have you did we take any extra space here in insertion sort? No. Then what is the space complexity? Constant, order of 1. So is it clear, everyone, this insertion sort? What about you, Pranjali, Likita, and others who are responding actively? Here, okay. So it's already 1.5. So I already wrote the program here, right? So try to do it in your systems and let me know if you have any doubts in the next session. So in today's session, we understood why data structures are useful and how can we achieve this searching, like how to search a particular element in given input, if it is sorted or if it is not sorted. And the linear search and binary search, and we understood how to calculate the time complexity and space complexity. And then we discussed a few sorting techniques. One is a bubble sort, selection sort, and insertion sort. Bubble sort, you have to do the comparison for adjacent elements on each iteration. And in selection sort, you need to get the minimum element among the given input, and you have to place it in its correct position. And insertion sort, you have, while adding itself, you have to make sure at which position you have to add that particular element. Okay. In next class, we'll discuss about merge sort. So because it is very useful and it is the optimized among all the sorting techniques. So hope you enjoyed today's session and you learned something new. So let me know if you have any doubt. And thank you, everyone. Over to you, Amar.
Yes, thank you so much, Surya. So, dear participant, just I shared the attendance link. So, please mark your attendance and share your valuable feedback. If you are facing any difficulty regarding the quizzes, regarding to the LMS, regarding to the material, please let me know in the chat box. I will be there for 2 minutes. Yeah, I'm sharing the attendance link once again. Okay, no, sir, all good. Thank you. Others? So for the verbal ability toppers, they mentioned that there will be a surprise gift, but I didn't receive any gift as topper. Yes, Peanut, team is in a plan. Definitely, you will receive an email shortly. So I will again update to the team. So probably by this week, it will be done. You're welcome. No, sir. Okay. You to participant, any issue? Yeah, your issues is all attendance link. So there is one question from Shiva. Yes, Shiva, I am able to read. No need to copy paste again and again. Okay. So still how many months you are providing this course? So we are done with the most of modules. We are done with the quantitative aptitude, logical reasoning, verbal ability, and soft skills. And we are turning the program. So and we are coming with the quantitative aptitude second part. After that, it will be done. Like it will take more 10 to 15 days. And if we require extra days for programming skills, we'll take that. Okay, Shiva. Okay, then thank you so much, dear participant, for attending today's session, and we'll see you on tomorrow at 6:30. So, bye bye. Have a nice day. Take care of yourself and take care of your family.